Hello learner, welcome to Manifested e-learning classes. My name is James Kenyani. We are going to proceed with the solutions to questions on the topic measurement. So straight away we shall go to the questions I had given in the previous lesson. So we shall go to question one by one. We go through the question and then we get the solution. So straight to the first question in the assignment. It's always good to go through the question because at sometimes it is easy to get the best format of the question before working the solution. Question 1. When preparing tea, water is mixed with milk. 500 centimeters cubed of water is mixed with 618 grams of milk. Calculate the density of the tea given that the density of water and milk is 1 gram. You find there is something that was to be added here, 1 gram per centimeters cubed and 1.03 grams per centimeters cubed respectively. Respectively means in that order. So we shall go to this question 1 solution. Solution. So in the solution, they are asking us to get the density of that tea. So density of tea, the density of the tea will be given by the mass of the tea divided by mass of divided by volume of tea, of the tea. Now there are two components there in the tea. We have water and milk. So you should get the total mass. So 1 mass of water mass of water, isn't it? The mass of water will be given by its density times the volume is equals to density of water times volume of water. So straight away, this is 1 gram per centimeter cubed times 500 centimeters cubed. That, if we work out, we get 500 grams. 500 grams, and we already know the volume of water. Volume of water is 500 centimeters cubed. Mass of milk the mass of the milk is already given 618 grams. And lastly, we have mass volume of milk will be mass of milk divided by density of milk. This is 618 grams. 618 grams divided by 1.03 grams per centimeter cubed. We work out, we shall get 600 centimeters cubed. So when we come to get the density of the tea, we are getting the density of the total mixture. So density of T will be given by, we'll take 618 grams plus 500 grams divide by, you'll get the volume of water plus, so we shall end up having 1118 divided by 1100 centimeters cubed. If you work out that well, you shall end up having 1.1064. 1.0164. 1.0164. That gives us the volume, which is also the density of the T. We shall go to the second question, having gone through that. Question 2. Question 2. The solution to question 2. So before we go to any solution, it's good to go through that particular question. It is always good to go through that particular question to understand its format before you go to that solution. A stopwatch, I think you've heard of a stopwatch, is used by students to take the time in a bread eating competition. The display on the stopwatch is 01.24.90. So express the time in seconds. Express the time in seconds. So you are given 01.2490. So before you work out, you should know what that represents on a stop clock, because most of them are standard. Most are standard. So you should know here, these are always minutes. The second one, these are always seconds. And this one, the last one, these ones are what you call centiseconds. Centiseconds. Centiseconds means 100th. A centisecond is 100th of a second. So in seconds, this will be equal to, we know a minute is made up of 60 seconds. 60 seconds make a minute. So we shall have 1 times 60 seconds plus, these are already seconds, so I don't need to convert, plus, I said 1 centisecond is equal to 0.01 seconds. So it is the one that will help me to get that one. So it will be 90 times 0.01 seconds. So I'll come and work out that. It will be 60 seconds plus 24 seconds plus 0.9 seconds. The sum of that 60 seconds plus 24 seconds, that is 84 seconds plus 0.9. It will give me 84.9 seconds. So always known as stopwatch. These are the minutes, these are the seconds, and these are the centiseconds. A centisecond is 100th of a second. That culminates to the solution of question 2. We come to question 3. It's good we can rub here because we are done with the solution of question 1. So we come to question 3, and as usual we go through the question, get the format, get the solution. Question 3, a defective watch. Defective means it's not working well, either too slow, too fast. A defective watch started after the button was pressed, after it delayed a bit. The time indicated that the stopwatch was 2.53. What was the correct time if the stopwatch took 0.3 seconds to stop after the stop button was pressed? So we are talking of errors. In most cases, we find errors. Even when athletes are running, we get one will start earlier. So this goes to the same thing to the defective watch. So the correct time, solution, this is question 3. So you should understand the correct time will be equal to, you are told, you look at the statement. It started after, after that. A defective was started. So there is something here we are supposed to add 0.5 seconds. 0.5 seconds. That's why it's good to go through the format. Go through that format. So a defective watch started 0.5 seconds after the button was pressed. So you go to that statement. It will be the delayed time when starting. You'll add to time recorded. Then you come to the, if the stop clock took 0.3 seconds to stop, it has added time that was not there. So in the last one, you should subtract. So here it was the time delayed, but here you are told took 0.3 seconds to stop. So you'll subtract time delayed at the end. So you'll come and have delayed time before you started, it was 0.5 seconds. The time recorded was 2.53 seconds. Then you'll subtract 0.3 seconds. So when you add this, you'll get 3.03 seconds. Subtract 0.3 seconds. You borrow 1 there. That is, no, you don't borrow. This is just 3. Borrow 1, 7, 2. So that was the correct time. That was the correct time. So it comes to another juncture where you'll get further questions. For the assignment. So those are the questions, and we shall go through them before you go and work them out. Question 1. A drug manufacturer gives the mass of an active ingredient. Active ingredient means the ingredients that will help you to heal if you have a certain disease in a tablet as 5 milligrams. Express the quantity in kilogram and give it in standard form. Question number 2. Quite long, but trying to build a concept there. In an experiment to determine the density of sand using a density bottle, the following were recorded. The following were recorded. Mass of the empty bottle, 43.2. Mass of the density bottle filled with water, 66.4. Mass of the density bottle with sand, only 67.5 grams. Mass of the density bottle filled with sand and water, 82.3 grams. Get it clear. Get it very clear. When it is filled with sand and water, water occupies only the spaces remaining above the sand. Use that information to determine the mass of the water that filled the bottle, the volume of the water that filled the bottle, the volume of the density bottle, the mass of sand, E, mass of water that filled the space above the sand, just what I've been explaining above, F, volume of the sand, and lastly, density of the sand. So thank you very much for the audience in the lesson, and have a good time as you go through those questions I've given in that assignment. Have a nice time. Let's meet in the next lesson. Bye-bye.